Okay guys, so this is going to be our second video, and this is going to be over the subject of lines. So let's see, let's just get right into it. Okay, so we're going to be doing lines. Okay, so what exactly is a line, right? We've seen a lot of them in our math classes before, right? So we have lines that go like this, we can have lines that go like this, we can have lines that go even horizontal, right? So what all these lines have in common is they're described by this: y equals mx plus b, right? Where your b and your m decide what type of line. So for example, in our case for the red, we have the line has a positive slope, right? So it's going to be going up and to the right. In case of green, the line has a negative slope, right? And what about the case of white? Well, there's no slope, right? So let's just remind ourselves what exactly slope is. So slope is just rise over run, right? So if we have a line like this, and let's say we have something like this, right? And if let's say we go through here, right? So the rise, we could pick any arbitrary points, but usually what you want to do is pick a rise at, where the points will intercept. So let's look at this point, and let's look at this point here. So in this case, we'll look at the rise first. The rise from this point to this point is, right, the rise from here to here is 2. There's 2 units, right? We go 1, 2, right? So there's 2 units up. Now let's look at the run. All right, so we start here, we go over 1, 2, 3. So for every 3 units we go to the right, we go 2 up, right? So to get from this point, call this point A, and to get to this point, point B, I need to go over 1, 2, 3, and then up 1, 2, right? So the slope is just going to be your rise over your run to get from point to point. So in this case, we went over 1, 2, 3, we went over 3, and our rise was 2. So your slope is 2 over 3. What's another way of writing slope? It's just m, right? That's our m. And that would be this part of our function here. So our function would look something like, this white line would look something like y equals 2 over 3x plus b, right? So we don't know what b is yet, and we'll get to that point. But at least we know what m is. M is 2 over 3, right? Because we went over again 1, 2, 3. When we started at point A, we had to go over 1, 2, 3. And to get to point B, you had to go up 1, 2, right? So that's essentially what we're talking about when we talk about what a line is. Now, if you're given 2 points, right? Let's say you have this. It's not always practical to, right? It's not always practical if you're given 2 points here and here, and let's say this is your x1, and its y value is y1, and this is your x2, and its y value is y2, right? It's not always practical to count. We don't want to have to count, right? We don't want to have to hop. We don't want to go 1, 2, 3, 4, right? We don't want to do that. So what you can do is you can get rise over run given 2 points on the line. They have to be on the line, like this point is A and this point is B. You can do y2 minus y1 is x2 minus x1, and that would be your slope. That would be the same thing as your slope. That's m. So again, now we can ask yourself, well, why can I do that, right? So this is my y2. We're saying this point here is our y2, and this point here is your y1, because if you look at this distance here, I'll highlight it. Let me get a different color here. Let's do this blue, right? If we look at this distance here from, that's not a good blue, I'm sorry guys. Let's look at, I don't know, what's going to pop up? Orange? Right? If we look at this distance here, that's what you're measuring when you do this, right? When you're saying, okay, to get this height here, right, you just subtract the height from this from that. That makes sense. So this whole thing, this is some point y1. It measures from 0, 0 to y1. y2 measures from 0, 0 to y2. And to get the difference, just to get this, you subtract them. And that's what you're doing here. And the same thing here, right? And the same thing for x. To get this distance here between x2 and x1, you would do x1 minus x2. Now I know it doesn't match up on a formula, but you can choose any 2 points, right? You can choose any 2 points to get the same slope. And any 2 points that are on the line and apply that formula. So let's look at this. Let's look at a question now. Let's say we're given, right? We're given a line and it goes through the origin, right? And there's a point on it. We have some point here. This point is AB, right? So this point's on a line, and the question says the line shown in the xy plane passes through this point AB, and A is bigger than B, right? Which could be the slope? So which could be the slope of this line? Negative 1/2, 3/4, 1, 3/2. So you're looking for the slope. You're looking for the rise over run, and we don't have any of our markers like this. We don't have that. All you know is that it goes through the origin, right? That this line goes through the origin. So pause the video and attempt to solve it, and then we'll do it together. So okay, hopefully you had a good a go at this and it went well. So let's look at our what we have to set up, right? So we know we have some line that goes through the origin, and it goes through this point AB, and we know that A is bigger than B, right? So we know that's true. Okay, so now let's see. So this point here is 0, 0, right? Now this point here, if I drop it down, of course this is A, right? And then this point here, this is B, right? Because this is AB. This is what this point is. And I know A is bigger than B, right? So if A is bigger than B, which one of these could be the slope, right? So what's our rise and what's our run? Well, if we start from 0, we ran all the way to A. We ran A places, right? So A would be on the bottom, and we rose B, right? So your slope is B over A, right? So we don't know what B over A is, right? It's not given to us, but what is given is that A is bigger than B. So we know whatever number on the bottom must be bigger than the number on the top. So let's go through knowing that and see if we can find one. So for example, let's look at this. This is negative 1/2. So we know for slope, if you're given a graph, you have a line, negative slope, they don't look like this, right? They look more like this, right? You're starting in the top left and you're ending in the bottom right. You don't start in the bottom left and in the right. The green lines are an example of negative slope. So we know negatives out already, so we can knock that out. Let's look at 3/4. So 3/4. So well, it does match what our two conditions are, right? That the bottom number 4 is bigger than the top number 3, right? So that's a possibility. Let's not mark it out. Let's look at one. This is 1. Well, another way, and you're saying, well, where's the other number? Well, another way you can do that is just 1/1, right? So this slope is a slope. If a line has a slope of 1, it means for every place you go over 1, you must go up 1, right? So that wouldn't be it, right? Because 1 isn't bigger than 1. It's the same thing, so we can mark that out. Now let's look at this one. This is 3/2, right? So 3/2 says that we go over to the right 2 places, and then you go up 3. Well, AB couldn't be on there, right? So could 2/3 be on the line? It couldn't be, right? Because if 2/3 were on the line, then we would go over 1, 2, and then it would be 1, 2, 3, and it should be something like that, right? So it couldn't be that. So what could be it? Well, let's see. What we have with the possibility is the last one remaining, which is 3/4. And that makes sense because we're going over 4 places, 1, 2, 3, 4, and then we go up 3, and what is A, right? So our point could be 4, 3, right? 1, 2, 3, 4, A equals 4, you're going up 3, B equals 3, So this point is in reality 4, 3. So the take-home message is just making sure we know rise over run, that your run A is larger than your rise B. Let's see. Okay, what's the next question? Okay, so we have a line M, right? Let's say we have a line M, and it passes through. Oh no, I misspelled that. My bad, guys. Through, right? Points K7 and 3k minus 4, right? And you know the slope is 3, right? What's the value of k? Find k, right? So let's draw it out real quick before you guys start. You're given this and you have a point here, right? And or you're given a line here and you know that there's 2 points on it, right? Let's say you have a k value. I don't know if this is accurate, if k is actually over here, but it's going to be something like this, right? Where you have a k and your point is k7 and then your other point is 3. So let's see if, let's say this is 3 and right, so that's 3, and then this would be k minus 4, something like that, right? So this point would be k minus, this point here, this x value would be on this line, be k minus 4 over 3 for your y value, right? So the idea is you know your slope is 3, you want to find k, and the line goes through these 2 points. So attempt to solve it, and then we'll come back at it. Okay, so hopefully you guys had a good attempt. So let's look what the question is asking, right? It tells you that the line goes through these 2 points, k7 and 3k minus 4, right? So these are 2 points on the line, right? So it could be like these 2 points here, A, B, right? And you have the slope equals 3. Well, what is slope, right? If we think about what slope is just simply rise over run, right? And rise over run is the same thing as doing y2 minus y1, x2 minus x1 for any 2 points that lie on the line. You can use this formula for any 2 points that lie on the line. Well, we have 2 points that lie on the line, right? We have this point here, point 1, and we have point 2, right? So let's just apply this. So we have k minus 4, let's start with this, k minus 4, minus 7 over 3 minus k. This all equals 3. Now let's say, well, how are you getting that? Well, I'll show you. On red, the points here on red, this is x, this is y. That's for some point, and then green, this is x, this is y. Well, this is the y for this point, and this is the x for this point. Here it is. This is the x for this point, and then of course for red, this is the y, and this is the x for that point, right? So you have your y value, right? K minus 4, that goes there. You have your y value for this point, 7. You have your x value, 3, and your x value here, k. We're just applying this formula here. Okay, so if we solve this, we'll have k minus 4 minus 7, right? This gives us k minus 11, so that's on top. On bottom, we just have 3 minus k, right? So we have k minus 11 over 3 minus k equals 3, right? Okay, so let's see what we can do now. We're just going to do some algebra here. So I'm going to multiply both sides by 3 minus k, right? That cancels this out. So you have k minus 11 equals 3 times 3 is 9, right? 3 minus k is minus 3k. Now we're going to solve for it. So we'll add plus 3k to both sides, right? So now what you'll get is 4k minus 11 equals 9. And then you'll get plus 11, 4k equals 20, right? Divide by 4, you get k equals 5, right? So what does that tell us? That tells us that these 2 points here, right? So now we're we almost, well, if you guys know slope or you know lines really well and this is all coming back, you have enough information to find the actual formula for this line. So basically we have this for sure. We have 5x plus b, right? And so we can find a formula, right? So we have 5x plus b. We know so actually this is done, right? If you get k minus 5, you're done, you're good. But I'm just going to go this extra step to show you what we can do with this info. So we have this form. We don't know what b is, but that's okay because we have a point, right? And one of the points, I can choose any of these points, but I'm going to choose this one. This is the easiest one, right? This is, we say k7 is on the point. So k is 5. So 5, 7 is on the line, right? So 5, 7 is on the line. I can just plug this in to get b, right? So I can do 7 equals 5 times 5 plus b, right? So that's 7 equals 25 plus b. That would give me negative 18 equals b, right? So now we have the entire line, right? So this is y equals 5x minus 18. So this line here has those 2 points up here that were given to us, right? So that's just an easy way to check your work, or to if they were to ask you another question like that. Okay, so let's say we have a line. Let's say they're giving us a line, right, that has a slope equal to 1/3, and it passes, and this line goes through the point through 1 minus 2, right? 1, negative 2. Find, right, which of these points lies on the line. Or D. Sorry. D. D is 4, 10. Right? So you have a line that has a slope of 1/3 and it passes through the point 1, negative 2. So just to draw, of course this isn't to scale. We can't just draw this and expect this to solve the answer for us. Actually wouldn't look like that. Wow. So, right, so you have a line here and we have x equals 1, right? And then on this value, negative 2, right? So this is actually a good exercise. Whenever you guys are doing a test, maybe draw out what you're given, and this will, actually this is not the right drawing either. See, I'm not paying attention. Don't do what I'm doing here. Do what I'm about to do right now. You have, the slope is 1/3, so what does that mean? We start on the left and we end in the bottom right, so it's a positive, right? And it passes through the point 1, negative 2, so it's going to be something like this, right? So you have 1 here, right, x equals 1, and then on this line, y equals negative 2, right? So, okay, so this is something like this. This is the picture we should be forming in our head, and we're going to work with that. Okay, so we have a slope 1/3, and it passes through this point. Okay, so let's see. So now what we need to do is we have y equals mx, our good friend b, right? We have the slope 1/3, so let's just replace what we have. So we can say, well, actually, y, we know is going to look something like this. 1/3 x plus b, right? So, well, we're good. So now what we need to do is we have a point 1, negative 2, right? So we're going to say negative 2 equals 1 times 1 plus b, right? So we're going to solve for this. So we'll get negative 2 equals 1/3 plus b. So I'm going to take away a minus 1/3 here. Negative 2 minus 1/3 equals b, right? So we got to convert this since we're adding a fraction, adding a negative fraction. So I'm going to put a 3 here. That means I need to multiply a 3 there. It would be negative 6 over 3. Minus 1/3 equals b, right? So that's negative 7 over 3 equals b, right? So we know what our b is. Now we have our entire formula now, right? So with this, now we got to plug in those points and see if we get one that's right. So let's see, what looks nice? Well, let's combine it. So we can actually say, since this is a 3, this is 3, it's going to be x minus 7 over 3, right? Because these two bases here are the same. The space here isn't the same, so you can just combine it and get this. So we have y equals x minus 7 over 3. We have our 4 points up here, right? So you can say, let's see, if we plug in a 4, right, you'll get negative 3. Actually, yeah, so it would be c, right? So looking at it, you can just kind of do the mental math, right? Let's look at c. C is 4, negative 1, right? If I plug in a 4, say y equals 4 minus 7 over 3, negative 3 over 3, negative 1, right? So we know our y value is 1, negative 1, so this matches up. But let's try another answer in case we didn't see that immediately. Let's try another answer, right? So, for example, b was negative 2, negative 1. This is what b. So if I say negative 2 for x, I get negative 7 over 3. This is going to be, what is that, negative 9 over 3, negative 3, right? That does not equal negative 1. So that point is not on the line. Right, so you just try more points and you will see if it's on the line or not. Anyway, what did I accidentally click? Okay. So let's try this, right? If we have a line that has ax plus 3y equals 15, right? A is a constant. A is a constant and has an x-intercept twice the value of the y-intercept. What is the value of A? So x-intercept twice value of y-intercept. Find value of A. Okay, so you guys are given a line here, and A is a constant, right? And you're looking for A, but you're also given this other fact: x-intercept is twice the value of the y-intercept, and now find the value of A. Okay, so give it a go, and let's see, we'll take it from there. Okay, so let's say we're given ax plus 3y equals 15. Okay, so we know the x-intercept is twice the value of the y-intercept. So that kind of tells us, let's look for the y-intercept first, because once we have the y-intercept, we just multiply it by 2 because it's saying the x-intercept is twice the value of the y-intercept. So the y-intercept is what? The y-intercept is when x is 0, right? So let's just plug in 0 for x. So we'll say a times 0 plus 3y equals 15, right? So that says 3y equals 15. Or, right, divided by 3 here, divided by 3, y equals 5, right? Okay, so now we have a y-intercept. The y-intercept is 5, right? So it just means when x is 0, y is 5. So now we know the x-intercept is going to be twice the value of the y-intercept, right? That's what it says up here. So then the x-intercept is 10, right? Or in other words, when y is 0, the x value is 10. So when you plug in 10 for this function, we should get 0 for y, right? So that's crucial. When you plug in 10 for this function, we'll just repeat it. When you plug in 10 for this function, the y value is 0. So let's go back to our original function, right? So I'm going to plug in 10 for x, right? So I'll say 10a plus 3y equals 15. But when I plug in 10 for x, y is 0. So really, this whole thing is just going to be 10a plus 3 times 0 equals 15, right? Well, that simplifies it immensely, right? So now we have 10a equals 15, right? Because 3 times 0 is 0. So now I can just divide by 10, or a equals 15 over 10. A equals 3 over 2, right? So we have our a-intercept, right? We have our value for a, right? So we have a equals 3 over 2. Okay, let's look at this really quick. Let's see if we can find another one. Let's see if there's another example. Okay, let's say we have, I think this is going to be the last example. All the other problems follow these examples. So after we do these examples, we'll post the problems, and you should be able to, the problems will look similar to the examples. Maybe there'll be slight modifications, but then I'm going to post a video to the solutions for the examples given. But anyway, so we have a line. We have another line given that passes through -2, 3, right? And 3 and 13, right? Find a y-intercept. Right, so you have a line given and it goes through these 2 points, and we want to find a y-intercept, or basically that's the y value when x is 0. Okay, so go ahead and pause and we'll pick up. Okay, so hopefully everything went well and you guys have an idea of what we need to do. So we have 2 points, right? So automatically we have 2 points. You have the slope, right? You have your rise and your run. So your rise here is going to be 13, right? For this value, you can do minus, now we do -3 for this, and you'll do 3, and you'll do a -2, right? So this is going to be 10 over, this becomes a 5, or 2, right? So your slope is 2. Slope equals 2. So now we're done. It's real simple. So you have, remember, y equals, if you just, I know you guys probably remember, this is one of the ways you guys remember most easily with a squared plus b squared equals c squared, but y equals mx plus b, we have our y, right? I'm sorry, we have our m, so y equals 2x plus b, right? So now we just need to find b. And we have a point, right? We have 3 and 13. So let's plug in 3 and 13. So we'll say 13 equals 2 times 3 plus b. This is 13 equals 6 plus b, or 7 equals b, right? So now your actual formula is going to be 2x plus 7, right? So at this point, we just got to find out whenever you plug in 0 for x, what do you get for y? Well, you can see y equals 2 times 0 plus 7, or y equals 7, right? So that's your y-intercept. So if you're given 2 points, just find the slope. The first thing we did was find the slope, right? Put it in a form, put in y equals mx plus b, right? Use one of the points given. We use this one just because they're both positive. And then you can isolate that and solve for b, right? And you get the y-intercept. Let's say we wanted to find the x-intercept, right? That's whenever that's the x value when y is 0, right? So you have y equals 2x plus 7, right? If you wanted to find the x-intercept, well, the x-intercept you'll just set this to 0, right? 2x plus 7, and you'll solve. So you'll say -7 equals 2x, or x equals -7 over 2, right? So what does that mean? That means, like, if the line looks something like this, I don't know if it does, if it looks something like this, right, this value here, let's say this is -7 over 2, this would be our y-intercept, right? This has been whenever y is 0, right? Because you have y, x here. Let's see if there's one more example we'll do. Yeah, this is not. This one's easy. Let's try this. So this is, you're given 2 lines, right? And you have line 1 equals y equals 3x minus 5, right? This is line 1, and line 2 is y equals -2x plus 10, right? And they intersect at point HK. Find value of k. Okay, so let's see. So go ahead and pause the video, and then we'll attempt to solve. Okay, so you have your two lines, right? And they intersect at point HK. So what does that mean? That means like if we have a graph like this and you have a line here, let's say this is line 1, I don't know if it is, and you have another line here, we'll say this is line 2, right? That means that they're going to collide at some point here. And this coordinate has an x value of h and a y value of k. It's not given to us, we don't know. And that's okay, right? But we know that their x values are going to be the same here, right? We know, well, their x and y values are going to be the same. So what we can do is we can set them equal to each other. We can say, we can set the two lines equal to each other and solve for that point. So we say 3x minus 5 equals negative 2x plus 10, right? So now we can solve for x here. So this is essentially our y value for this line. We'll call that y1, and this is our y2. So you're really setting the y values equal to each other here. You're setting these two y values equal to each other, but that's not important. What's important is we can find out what that value is by solving for x. So we can say 3x, let's get all the x's on one side, plus 2x equals, sorry, so I'll do this, make sure I show all my steps. This is minus 5. So we're adding a 2x, so this goes to 0. Right, so you have 10 here. So let's condense this. You get 5x minus 5 equals 10, or 5x equals 15. Right, divided by 5, you get x equals 3. Okay, so what does that tell us? That tells us that x equals 3. These two lines are going to collide. So it'd actually be somewhere over here. Your two lines will look something like this. Now that we got more information, we can draw this more accurately. You'll have a line over here, and you'll have a line over here, right? So like, let's say x is 3, right? But we don't know the y value yet, right? So that's okay though, because it's easy, right? But we have the x value, and there can only be one x value. So we have this x value, we can plug it in either one, right? Let's plug it in this one. So we do 3 times 3 minus 5 will give us 4, right? Did that quick. So 3 times 3 is 9 minus 5 equals 4. Let's double check, right? Let's check this one. Negative 2 times 3 plus 10, that'll give you negative 6 plus 10. Well, that's just 4 too, right? So that tells us that these lines do, in fact, meet at this point, which is 3, 4. This is an interesting property about lines. You wouldn't be able to say this for other functions. So like if you had a parabola, right, you could actually have them meet at more than one point. So you could just say, okay, well, I'm going to solve them. You could get, there's two different x values that could meet up. So, but at least for lines, you can just set them equal to each other. If you see the word intersect in our problem, you can just set them equal to each other and solve for them, and you'll find the same x and y value that they share. The last thing I want to go over with you guys is if you're given, of course, two graphs like this, and you're looking for, like, if they give you this and they ask you what's the slope or what's the equation of this line and what's the equation of this line. So we'll say this is graph 1 here, right, and this is graph 2. So for graph 1, this line is just going to be, let's say this is, of course this is on a positive side, so this is be x equals 5. So this is just going to be all the points for x equals 5. So this will have, of course, 5, 0, and this will have 5, 10, and this will have, if you go way up here, you'll have x equals 5, 1,000,000, or whatever, right? Same thing here, you just go all the negative values. So this graph would be x equals 5. It's just every single y value with the x coordinate being 5. And on this one, this is just going to be y equals, so since it's positive, you could choose a number 7, right? So this is going to be, again, every x value, right, that has a 7 in the y area. So you can choose any value for x, and it will just go off to negative infinity and positive infinity. So hopefully this made sense. I'm going to post some more questions, and they should follow these examples, and just refer back to the video as needed. But let me know what you guys think about it. Okay, thanks.